The stillness of the midnight hour in November 2025 pressed in around me, a velvet cloak woven from the silence of the sleeping city, broken only by the incessant, low hum of the laptop fan, a tiny mechanical breath in the vast quiet. Outside the window, the autumn wind, a keen, spectral presence, whispered secrets through the skeletal branches of the last few clinging leaves, carrying the damp, earthy scent of decay and regeneration. Above the rooftops, the sky was an infinite, inky void, punctuated by the shy, distant glimmers of stars, like ancient, unblinking eyes silently cataloguing our transient existence. It was in this profound solitude, bathed in the pale, cool luminescence reflecting off the screen, that the inevitable question resurfaced, sharp and piercing. Are we merely fleeting silhouettes on a monumental stage, observed by other worlds, by other iterations of ourselves, peering back from some unseen aperture in the fabric of reality? This was not merely the fertile ground for speculative fiction, it was a deep, existential mystery that simultaneously sparked profound loneliness and exhilarating excitement, quickening the pulse when contemplating the possibility that our entire universe is but a fragile layer in an infinitely complex tapestry woven from myriad dimensions. To properly navigate this abyss of the unseen, we must first rewind the reel of scientific endeavor, back to the nascent years of the 20th century, imagining the great architect, Albert Einstein, hunched over his desk in a modest office in Princeton, the scratching of his pencil against paper the only punctuation in the dense quiet, the faint, lingering aroma of stale coffee clouding the air. Einstein, with his revolutionary theories of relativity, redrew the map of reality, conceiving of the cosmos as a unified, four-dimensional continuum, the familiar three spatial dimensions we navigate daily, coupled inexorably with the unidirectional flow of time. Yet, the quest for deeper unity persisted, and by 1919, the mathematicians Theodore Kaluza and Kaluza-Klein introduced a concept so radical it felt like heresy. What if there were additional spatial dimensions, curled up so tightly at the subatomic level that they remained imperceptible to our macroscopic senses? Think of a garden hose viewed from 50 yards away. It appears as a one-dimensional line, flat and featureless, but upon closer inspection, one discovers its hidden, circular depth. This is the proposed geometry of these extra dimensions, compactified perhaps at the Planck scale, approximately 10 to the power of negative 35 meters, a scale unimaginably smaller than even the smallest proton. Crucially, this intellectual construct was not mere philosophical musing, it provided a potential mechanism to organically unify electromagnetism with gravity, offering a tantalizing hint that the universe harbored layers of existence far exceeding our immediate perceptive grasp. The journey deepens as we transition into the realm of quantum mechanics, where intuition dissolves entirely, punctuated by the precise, cold ticking of atomic clocks within sterile laboratories, like those near Geneva, home to the Large Hadron Collider, or LHC. Here, fundamental particles are smashed together with energies reminiscent of the universe's very first moments, recreating miniature Big Bangs. Quantum field theory posits that particles are not solid entities but rather localized excitations, vibrations, within pervasive energy fields. To reconcile the stark difference in strength between the fundamental forces, why gravity is so comparatively feeble against the robust electromagnetic force, physicists like Edward Witten, in the mid-1990s, formalized the string theory. This model paints the universe not as being constructed from rigid, discrete Lego bricks, but from infinitesimally small, vibrating filaments, like cosmic guitar strings, where the harmonious existence of these vibrations necessitates the presence of 10 spatial dimensions, 3 large ones and 6 extra dimensions tightly coiled, forming intricate Calabi-Yau manifolds, hidden topological spaces woven into the very fabric of pure energy. These hidden dimensions are not broad avenues for movement, they are submicroscopic loops, geometries where fundamental particles experience their presence through subtle, measurable quantum effects. Fast forward to 2025, and the scientific community is buzzing. Research groups affiliated with the LHCb, ATLAS, and CMS experiments, recently honored with a breakthrough prize in fundamental physics, have been rigorously utilizing the LHC's vast datasets to hunt for the indirect signatures of these extra dimensions, primarily by tracking the anomalous disappearance of the graviton, the hypothetical messenger particle of gravity, into these unseen realms. While direct detection remains elusive, these colossal experiments, marked by the deep thrum of superconducting magnets and the brief, violent flashes captured by detectors miles beneath the Earth, evoke the thrilling sensation of excavating an ancient tomb, perhaps uncovering the very Rosetta Stone of physical reality. But if these compactified dimensions truly exist, they invariably lead to an even more staggering implication: the multiverse, the notion of parallel universes where every quantum possibility actualizes into a separate branch of reality. Picture standing at a literal fork in a dense, ancient forest, the air thick with the rustle of falling leaves and the smell of moist soil, and as you commit to the left path, an alternate version of yourself chooses the right, both resulting realities persisting, existing in parallel, overlapping strata of existence. This is the many worlds interpretation, first proposed by Hugh Everett in 1957, a young man wrestling with the paradoxes of quantum measurement in a quiet Princeton library, the sound of turning pages echoing his internal struggle. Everett argued that when an electron facing a double-slit experiment chooses to spin up or down, the universe does not collapse into a single outcome. Instead, the entire cosmos bifurcates into two distinct realities, each accommodating one outcome. The feeling this provokes is deeply unsettling yet strangely comforting. Every regretted moment of your life, that clumsy word spoken during a rain-drizzled date, that missed career opportunity amidst the laughter of colleagues, is vividly playing out somewhere else, in an adjacent dimension, suggesting that, perhaps, total failure is an impossibility in the grand accounting of existence. The newest data points from 2025 lend an almost alarming tangibility to this abstract concept. In a compelling feature in Scientific American, leading physicists debated how Google's Willow quantum chip appeared to be borrowing computational power from these parallel universes, achieving processing speeds so exponentially superior that Hartmut Neven himself described the phenomenon as a momentary crack in the wall of the multiverse. Envision the engineers at the Google Quantum AI Lab in California, gathered around workstations, the rapid clicks of keyboards mingling with the sweet scent of freshly baked cookies wafting from the cafeteria, witnessing a quantum computer solve problems in mere minutes that would require millennia for the most powerful classical supercomputers. This observation suggests that, within the framework of the many worlds interpretation, qubits, the fundamental units of quantum information, are not merely existing in superposition. They are actively exploring an almost infinite array of simultaneous realities, generating an almost dizzying sense of excitement, as if we are momentarily grasping the very threads of a multidimensional fate. Furthermore, the theory of eternal inflation, refined by Andre Linde and Alan Guth, saw further computational modeling in 2025, documented in Quanta magazine, which depicts our universe as one expanding bubble within an infinite ocean of other bubbles. Following the initial rapid expansion post-Big Bang, space continues to inflate differentially, creating isolated pockets where the fundamental physical constants vary wildly. In one bubble, gravity might be so strong that stars cannot form. In another, the electron mass might be lighter, leading to alien planetary systems supporting bizarre forms of life. These bubbles, separated by colossal, energetic gulfs, exist in parallel, and if they undergo a gentle collision, the residual imprint might manifest as a faint circular pattern observable within the cosmic microwave background radiation, a faint ring on the CMB map, a scar testifying to an interreality impact. So, are these parallel dimensions actively observing us? The very thought conjures a primal fear, akin to the chilling whisper heard down a long, dark corridor in an aging house, the undeniable sensation of unseen eyes tracking one's movements from the shadows. In the Brane-World model, pioneered by Lisa Randall and Randall-Sundrum in 1999, our familiar three-dimensional universe is confined to a thin brain floating within a higher dimensional space, and the perplexing weakness of gravity is explained by the hypothesis that gravitons can leak or bleed into these adjacent brands, effectively diluting their force across the larger structure, as if unseen worlds are siphoning off some of its power. By 2025, investigations at the LHC are intently focused on searching for microscopic black holes, tiny, energetic spheres predicted to form if gravitons momentarily cross into the fifth dimension, the massive detectors registering particle collisions amidst the cold air tunneling beneath the Alps, the air thick with the ozone tang of intense electromagnetic fields. Though definitive evidence remains absent, a groundbreaking study emanating from Nanjing University, employing highly sensitive quantum sensors based on nitrogen vacancy centers within diamond crystals, atomic defects exquisitely sensitive to minute shifts in fundamental constants, has expanded the search spectrum into the terahertz frequency range, potentially offering a new window onto dark matter interactions and the geometry of hidden dimensions, rendering the experience akin to straining to hear a faint, rhythmic tapping emanating from a neighboring existence. One can picture the researchers there, hands steady despite the profound nature of their work, handling diamond samples that shimmer under the harsh fluorescent lighting, sensing the subtle vibrations that might betray the presence of another world pressing against the delicate membrane separating realities. But the influence of these concepts is not confined to the sterile environment of theoretical physics. They have deeply permeated culture and the ubiquitous discourse of our networked society, manifesting vividly on social media platform X, where astonishment and anxiety coalesce under the blue-white glow of late-night screens. In November 2025, physicist Paul Halpern published a widely discussed piece accompanying his new book, The Allure of the Multiverse, charting the journey from extra dimensions to time travel in speculative fiction, garnering thousands of likes and comments from enthusiasts huddled in cozy coffee shops, the sound of the grinder a constant backdrop, passionately debating whether the persistent sightings of UAPs, unidentified aerial phenomena, are, in fact, temporal or dimensional tourists. A particularly viral post by the user _the prophet _ analyzed a proposed interdimensional model for UAPs, positing them as post-biological entities observing humanity without overt intervention, accumulating over 17,000 views and sparking intense debate on their alleged concentration around nuclear facilities, perhaps because nuclear detonations generate gravitational or dimensional ripples, an energetic echo that traverses the layered realities. Concurrently, another thread by user at _vision discussed resonantia veritas fractalis, the resonance of fractal truth across dimensions, suggesting we have already encountered our counterparts in other universes, invoking a strange, shared intimacy, like a familiar whisper remembered from a dream. These digital conversations, punctuated by the tap-tap-tap of keyboards and hushed laughter in private group chats, form an emotional web where the fear of observation transmutes into the joy of shared cosmic speculation, fostering a profound sense of connection to the immense, uncharted scale of existence. However, not all voices are steeped in optimism. Skepticism rings out like a sharp gust of wind howling through a poorly sealed window during a storm, grounding the discussion with empirical necessity. Critics such as George F. R. Ellis maintain that the multiverse hypothesis suffers from a critical lack of falsifiability. As these parallel universes are, by definition, causally disconnected, it is akin to asserting the existence of a vibrant, populous jungle beyond a mountain range too steep and high ever to be scaled or observed. In a pointed Forbes blog entry from 2020, physicist Ethan Siegel dismissed them as science fiction daydreams, given the available data, inducing a melancholic pang, like staring across an ocean vast enough to suggest no opposite shore exists. Yet, the advancements of 2025 inject renewed vigor into the debate. A meta-multiverse analysis conducted on the platform Editverse synthesized cutting-edge quantum data with statistical modeling to probe the geometry of parallel reality, employing mathematical frameworks derived from Max Tegmark's concept of the mathematical universe, where every coherent mathematical structure corresponds to a physical reality unto itself. Visualize the mathematicians at MIT, gathered in a seminar room where the squeak of chalk against the blackboard provides rhythm, sketching out complex fractal equations representing boundless possibilities, and suddenly, a specific model predicts a subtle anomaly in the Planck telescope's CMB data, those faint circular patterns that might just be the remnants of a bubble universe collision. Furthermore, the theoretical scaffolding of extra dimensions offers compelling solutions to physics' most vexing puzzles, notably the hierarchy problem. Why is the mass of the Higgs boson so incredibly small, roughly 1 to the power of -17 times the magnitude of the Planck scale, rendering our universe gravitationally stable instead of collapsing instantaneously? In a novel model published in Advanced Science News. In November 2025, the introduction of 2 dark dimensions, compactified at a specific, reachable scale, mathematically reduces the effective gravitational force down to the scale of 10 tera electron volts, a regime tantalizingly close to the energies accessible by the LHC, with experimental confirmation potentially within the next 3 to 5 years, heralded by the surging sound of particle acceleration and the sharp scent of ozone generated by high-voltage electrical systems. This is not purely academic speculation, it heralds potential technological leaps, such as quantum computers harnessing the geometry of the hidden dimensions for unprecedented computational speed, or perhaps even realizing mechanisms for traversing space by subtly manipulating the extra dimensions, a prospect that ignites a fierce, almost physical excitement, like standing atop a precipice surveying the fog-shrouded valley of the future. In conclusion, while the ledger remains conspicuously empty of definitive proof, no vanishing gravitons confirmed, no heavy Kaluza-Klein particles detected beyond expected mass ranges, the very contemplation of parallel dimensions observing us ignites a deep, resonant conviction regarding the immensity of existence. We inhabit an era where the Europa Clipper probe is already en route to Jupiter's icy moon, methodically drilling into the frozen crust in search of simple subsurface life, and where the Vera C. Rubin Observatory is about to commence its decade-long survey, diligently cataloguing the skies for exoplanets orbiting distant stars. If parallel worlds truly exist, it is a comforting symmetry to assume they are engaging in their own rigorous astronomical searches, perhaps exchanging subtle quantum signals across that fragile boundary of reality, and in that shared act of cosmic curiosity, the sharp edge of our solitude might finally dissipate, like morning mist beneath a rising sun. Until that profound moment of contact, or definitive confirmation, we are compelled to look upward, listen intently to the universe's whispers, carrying an open heart and an unbounded mind, for it is within the profound darkness of the unseen dimensions that the brightest, untold stories of reality may yet reside.